In this video, we're going to be finding the inverse function of trigonometric functions. So we've got a function f of x equals 2 sine x minus 1, and it's only going to be defined on the closed interval from negative pi over 2 to pi over 2. Okay, that way that there is an inverse that exists here. So finding the inverse, step one, when you find the inverse, I'm going to replace f of x with y. Okay, so what does that look like? So f of x equals 2 sine x minus 1 becomes y equals 2 sine x minus 1. And now for my next trick, I'm going to swap x and y to find the inverse, okay? When I do this, I get x equals 2 sine y minus 1. Okay, now what I want to do is I want to solve for y. So easy steps here. Replace f of x with y, swap x and y, solve for y. So when I solve for y, what is that going to look like? Well, I have x equals 2 sine y minus 1, so I'm going to add 1 to both sides. So I have x plus 1 equals 2 sine y. Then I'm going to divide both sides by 2. So the sine of y is equal to x plus 1 over 2. Okay, to get y by itself, I need to get rid of the sine function. The inverse sine will help me do this. Sine inverse sine y gets me sine inverse x plus 1 over 2. These cancel, so I have y is equal to sine inverse x plus 1 over 2. Now the last step, replace y with f inverse of x, and you have your answer. Okay, so this is the last step. So my answer, f inverse of x is equal to sine inverse of x plus 1 over 2. That is the inverse function for what I started with right here, 2 sine x minus 1. All right? Now, second part of the problem asks you to find the range of f and the domain and range of f inverse. Okay, so let's go back to f. So f of x is equal to 2 sine x minus 1. I agree. The domain of this function was told to us. The domain here was negative pi over 2 to pi over 2. Okay, that was told to us in the problem. We were given this here. Okay. What I'm looking for now is the range. So what is varying here? Well, it's the x that varies. What do we know about the sine function? The sine function passes through the origin, goes up, peaks out, and then goes up, peaks out, and does this forever. What is the highest value that it attains? Sine of x is always going to be less than or equal to 1, okay? But it's always going to be greater than or equal to negative 1. So it's greater than or equal to negative 1. All right, so what does that tell me? Well, that tells me this number here is varying between negative 1 and positive 1. Okay, so how am I going to use that to help me figure out my range? Well, let's just take this. Replace this with y. So I have y equals 2 sine x minus 1. So let's just start working this out, trying to solve for x. Okay, so we can see if we can't figure out, where we're stuck between. Okay, so add 1, add 1. Okay. So what's that going to do for me? Well, that's going to get me 2 sine x equals y plus 1. Okay. And then divide by 2, divide by 2. So it gets me sine x is equal to y plus 1 over 2. Now, what do we know about sine x? It's stuck between negative 1 and positive 1, right? Well, what do we know about sine x and y plus 1 over 2? They are equal to each other. So I'm going to replace sine x with y plus 1 over 2. So it's stuck between negative 1 and positive 1. And I'm going to solve, and I'm going to get a range bound for my y values. Okay? And once I do that, multiply through by 2, I get negative 2. Less than or equal to y plus 1, less than or equal to 2. Subtract 1, subtract 1, subtract 1. I get negative 3, less than or equal to y, less than or equal to positive 1. So that tells me that the range is negative 3 to positive 1. Okay, this is for f. If I want to know the domain and the range for the inverse, what do I know the inverse does? The domain and range for f inverse is the opposite. So the x becomes the y, so the domain becomes negative 3 to 1, and the range becomes the domain, so this is negative pi over 2 to pi over 2. Excuse me. Okay. So that's how you find the inverse and then get your range.